All right, and the slides are good. Oh, we've got some. Okay. So let's go ahead and get started. My name is Saad. I'm one of the co-chairs of SIG Storage, and today I wanted to give you an intro as well as a deep dive for SIG Storage. So at a very high level, I want to introduce what this SIG is, what we do, how you can get involved, and then we're going to have some presentations by Michelle and David, who are members of Storage SIG, on the work that they're working on, and we're going to wrap it up with a Q&A with some of the veteran members of the SIG, and you can ask any questions you have about individual projects, anything that's in your mind, that's on your mind regarding storage and how to get involved with SIG Storage. All right, so first up, what is this group responsible for? We are responsible for the Kubernetes Storage subsystem, the volume subsystem that probably most of you have some familiarity with. We are specifically responsible for ensuring file and block storage are available wherever a container is scheduled. Storage means a lot of things. SIG Storage focuses on file and block specifically because that's the turtle at the bottom. That's where the rubber meets the road. And we are able to create an abstraction layer there because the data path has been standardized. The way that you read and write to block, the way that you read and write to file doesn't require your application to change. That logic is built into your operating system. And so what we can do is build volume plugins and logic that allows us to take any arbitrary block and file and pipe it into your running container and allow you to be able to persist your bits. So that's the high level of what we're responsible for. Specifically, the functionality that we focus on is provisioning block and file volumes, attaching them, meaning once your pod gets scheduled, it gets scheduled to some node. If that disk is not available on that node, making sure it is available on that node, mounting it, making sure that that volume is available inside the container to read and write, and then of course the reverse operations. That's the core of what we focus on. You're going to hear a lot more about some of the new features that we're working on later today. We also influence scheduling, so there's a lot of work going on to make sure that when a pod is scheduled, we also make sure that storage is taken into account. If you have a volume that a pod consumes and that volume is not available to all the nodes within the cluster, we want to make sure that we make the correct scheduling decisions there to ensure that your pod lands on a machine that can actually access that storage. And then we also try to influence where a volume is going to be provisioned. So as we make the determination of where a pod should be scheduled, we can make we can influence exactly where the volume should be provisioned before it gets provisioned. And then we're responsible for storage capacity management. Think of the volumes when they're provisioned are a specific size. We give you the capability of being able to resize that volume and then managing quota on the storage pools that you have available. Now let's talk about some of the features that SIG Storage owns. The most famous are the persistent volume claim and persistent volume API objects. These objects enable you to consume storage, block and file storage, in a portable manner. So your pod files will point to a PVC, and then your PVC points to a specific instance of a block or file storage system. And the beauty of this interface is that if you take your application definition and your application and you move it to a different cluster which has a different block and file, things will just work. You don't actually have to change anything. And then storage classes enable dynamic provisioning and also enable this portability. That's another API resource that we own. And then we own, these API objects I talked about are kind of the northbound APIs that we expose. These are APIs consumed by the end user or by people using Kubernetes. A second set of APIs that we expose are southbound APIs, which allow storage vendors to be able to plug themselves into Kubernetes. And the main API there is called the Container Storage Interface, CSI. You're going to hear a lot about that. That enables a storage vendor to write a driver to integrate their storage system with Kubernetes. And then if you have a Kubernetes cluster, you can deploy a CSI driver as a Kubernetes workload and basically extend Kubernetes to know how to talk to this specific block or file storage. In addition to persistent storage, this team is also responsible for ephemeral storage. The basic example of that is the empty dir volume. The idea there is that if you want to have some sort of scratch space that multiple containers within your pod share, you create an empty dir. It'll take a little bit of scratch space from the host machine and it'll mount it into into all the containers in your pod. And then you can read and write from them simultaneously. And then when your pod is terminated, all of it goes away. And we build on top of that empty dir with a few volume plugins that are more specific, that are pre-populated essentially. So the Kubernetes API has, for example, secrets as a way to be able to store secrets as a way to be able to manage the confidential things within your cluster. You don't want those things to be hard-coded into your containers. You want them to be managed separately. You can always access the Kubernetes API to fetch secrets and config maps and these other API objects, but in order to make it easy to be able to consume those things, we also allow you to expose those things as volumes inside of your container so you can read and write them from a file. A lot of existing applications know how to consume configuration and secret information as files, so you don't have to modify your application to go and reach out to a Kubernetes API server. You can just do what you're used to. And those volume functionality for secrets and config maps is built on top of empty dir. We'll create an empty dir, we'll pre-populate it with what you requested, and we'll mount it into your container to make it available to you. So those are kind of the high-level things that we are responsible for. If you're interested in finding out more about our team, please take a look at our community page. It has all the information that you need on how to get in touch with us and what we're working on and so on and so forth. Who is SIG Storage? SIG Storage is contributors from a diverse background. They fall into two major categories. One is storage vendors who are interested in integrating with Kubernetes, and the second is consumers or users of Kubernetes. This could be PaaS, people who create PaaSes, or end users or consumers themselves. So we have folks represented from a number of companies, as you can see on this list, and that is an incomplete list. It's a lot longer than that now. So what do we do day to day? Our day-to-day responsibility is to code features, to write tests, to fix bugs related to the features that I mentioned earlier. We meet virtually every 2 weeks to plan and discuss. So we have a meeting on Zoom at 9 a.m. Pacific time on Thursdays. And then every now and then we do a face-to-face meeting where we'll come together as a SIG and do a couple days together at some location, which changes, to hammer out kind of larger design discussions. We've realized that in the past it's been very helpful to unblock us when there are kind of big contentious issues that we don't know how to move forward on. Often those are difficult to resolve on a 1 hour video conference. So having folks come together and just hammer it out over a couple of days has been very helpful for us. And then, of course, we're available on Slack and Google Groups, as those are the two tools that we use to communicate with each other. And if you have questions, those are good places to get started. So let's talk about what we've been working on in the last release. Kubernetes 1.14 had a number of features. The highlight of this release was local PVs went GA. Local persistent volumes now allow you to consume consume storage that is local to a specific node. So if you can imagine, you have a number of nodes, they have disks attached to them. Those disks are only available to that node. Traditionally, what we've done with Kubernetes is we've assumed that persistent storage is network attached, so that if your workload moves around, your storage moves around with it. But of course, there are performance implications for doing so, and there are applications that want to be able to consume faster, high-performance storage that is locally available on the machine. There are drawbacks for doing so, namely replication must be handled at the application layer, but it is a legitimate use case for things like software-defined storage systems and databases that handle replication. And so we're very proud to have that feature move to GA. Prior to this, folks were using host path, which was a really bad hack. Basically, Kubernetes didn't know how to handle host path, so it would move your containers around and you would lose your data. With local PVs, the scheduler is natively aware that this is a special type of volume. Once you start using it, your workload is sticky to the same node. So that is local PVs. The next is CSI. We're adding a number of features here. CSI went GA at the end of last year, Q4, Kubernetes 1.13. And CSI is now our southbound API, so we're continuing to add additional functionality to it. The functionality that we've added in 1.14 for beta was raw block volumes and topology. Raw block is, I keep saying file and block, file and block. The reality is that the Kubernetes volume subsystem has been mostly file. And very recently we started introducing the ability to consume raw block devices. So instead of having a file system applied on a volume and having that exposed at a specific directory inside your container, this feature allows you to actually have the raw block device exposed directly into your container. And this is functionality that would be useful to some databases that don't want to write through a file system. They want to kind of have direct access and do their own thing on the disk. And then we have topology moving to beta. I talked about how Kubernetes is able to intelligently schedule workloads based on where a volume is available, and also able to intelligently provision volumes. With CSI, we want to extend this in a more generic way. So if you are a storage vendor, you're able to expose or integrate into this functionality. And the way that we do that is with this topology feature. And then we have resizing introduced as alpha. This is, you've provisioned a volume, let's say it's 20 gigs, and later you realize that wasn't enough space. You want to be able to resize it. This functionality exists in the core for some of the entry volumes. And the way that it works is you modify your PVC, change the capacity, and that triggers a resize operation. Now we're introducing the same functionality for CSI drivers, and that went to alpha. And then the big feature that we're going to be working on over the next few quarters that will have very little end user kind of noticeable functionality difference, but will be huge for the infrastructure, is migrating entry volume plugins to CSI. When we first started Kubernetes, all the volume plugins were baked into the core of Kubernetes. They were shipped as part of the binaries. But that quickly became unsustainable, and David's going to talk to you a little bit more about that. We invented CSI as an extension mechanism, and now that's GA'd. But what we don't want is to continue to maintain both entry volume drivers and external CSI drivers. So for the entry drivers, we plan to have a way to be able to migrate those out of tree and use CSI. Again, David will talk more about this. And then finally, we've developed a pluggable end-to-end test framework. The idea here is that a lot of these volume plugins that we have, when we first started, each one of them had a custom set of tests written for them. And the set of tests were different for every volume plugin, and some had some tests missing, some had other tests missing. It wasn't consistent. And Michelle and Aaron and Patrick, Oli, and all of a lot of folks in SIG Storage got together and they created a framework that allows us to write the test once and be able to plug in different types of volume plugins to it. So we could have one set of tests that we can run against multiple different volume drivers. And that project just completed, and now storage vendors should be able to use that to test their own CSI drivers. What are we working on this quarter? Code freeze is end of this month. So the things that we're working on right now are migrating entry volumes to CSI. So we're continuing to add additional functionality here. We were hoping to move this to beta this quarter, but we realized we needed to make a API change. And whenever you introduce a Kubernetes API change, we first need to go to alpha before we go to beta. So while functionally I think we're going to be beta ready, in terms of the official designation, we're going to keep it at alpha this quarter. And then in terms of CSI features, we're going to move those along. I mentioned resizing was alpha last quarter. It's going to be moved to beta this quarter. And then we're going to be introducing ephemeral inline volumes. So the idea here is I talked about empty dir and secret volumes and that kind of thing. Those are entry core baked volume plugins. We want people to be able to write plugins like that using CSI, and this ephemeral inline volume feature allows that to happen. And then volume capacity and usage metrics. So for the entry volume plugins, you can get metrics in terms of how much space you're using on a volume, how much capacity you have available. CSI hadn't wired that up, and thanks to a lot of the work by Humble and Hemant, that has been completed for this next release. In addition to that, we are moving along the volume snapshot project. Volume snapshots is the ability to take a snapshot of your volume through the Kubernetes API instead of having to go around it and talk to the storage system directly. This is important for disaster recovery and a number of other use cases. The alpha functionality for snapshots was introduced in 1.12, 1.13. The feature itself is going to remain in alpha this quarter, but we're adding some additional functionality, including the ability to have QS and un-QS hooks at the application layer, as well as beginning to design volume consistency groups. The idea here is that you can group multiple volumes together and ensure that reads and writes to them are consistent across the group. And then when you take a snapshot, the snapshot is taken of all the volumes in a crash consistent manner across all the volumes, not just a single volume. We are also working on an implementation of cloning. I'm not sure if it's going to make it in this quarter. The design was approved. The implementation is in progress. The idea here is instead of having to snapshot a volume and then rehydrate it, you should be able to create a copy on write duplicate of a volume and of an existing PVC and use that. So we'll see if that gets in. And then finally, we're designing volume attach limits. This is a feature that exists in core. The idea is that a particular storage system may have some sort of maximum limit in terms of how many volumes can be attached to a given node. We want to be able to generally express that in CSI. The feature was beta in the core. And then when CSI came along, we decided we wanted to kind of redesign it to make sure it works well for both CSI as well as for entry. All right, next up, how do you get involved? So if any of this sounds interesting to you and you're interested in getting involved, start at that storage SIG page that I mentioned and start attending the bi-weekly meetings. Again, they're 9 a.m. Pacific time every Thursday. It's a Zoom meeting. You can attend from anywhere. There's an agenda doc. Feel free to add to that agenda doc if there's something that you want to address. The next meeting is going to be on June 6th. There's supposed to be a meeting this morning, but we canceled that because of KubeCon. So the next one will be June 6th, and we're going to do Q3 planning. The way that it works is every 2 weeks we will do status updates for the projects that the tasks that we're working on for the SIG. And then once a quarter, we do planning for what we're going to work on next quarter. So for Q3, the planning is going to start June 6th. And if you're interested in starting small, familiarize yourself with the code. Start with the main method and just walk through it. That's the best way I know of learning a new code base. And look at the bugs that we have opened. Look for the label SIG Storage and help wanted. As of April 28th, there were 294 SIG storage bugs, so If there's anything there that interests you, please reach out to one of us and we'd be happy to help you get started. And please help us write more tests. This is very important. Storage is something that you can't mess up, and it's absolutely it's absolutely critical for the stability of a system. And the best thing that we can do is write more tests and ensure the system is stable. So if you're interested in that, please reach out to us. Right now, we're really looking into scalability testing, something that we really want to do, but we haven't had folks to help us with that. So if you're interested in that, let us know. We'll give you access to a 5,000 node cluster, and it'll be a lot of fun. And of course, you can also help us write features. There's a new version of Kubernetes released every quarter. And like I mentioned, we do quarterly planning. So if you're interested, show up at those quarterly planning meetings. And if there's a task you're interested in helping with, we'll put your name on it, and you can own that end to end. The release schedules you can find at this link. We have a storage planning spreadsheet, which we use to keep track of all the work that the SIG is working on. And then just a reminder in terms of process, the way that it works is the Kubernetes release team keeps track of what features are being developed through two things. One is a feature issue, which is under the Kubernetes enhancement repo. For that particular feature, and this is kind of used as a core, so to track what documentation needs to be added, release notes, all of that. And then the second is now there's a requirement for a KEP, which you can think of as a design doc that needs to be created for a feature that's being added. And we can walk you through this if you are ever interested in helping us write a feature. The coloring on this is beautiful. But there were a number of talks by SIG Storage members at KubeCon Barcelona. Please check them out. The recordings are going to be online. There's a lot of informative content from a very high-level overview to deep dives on specific storage functionality. And that is all. I'm going to hand it over to Michelle and then David. Thank you.
All right, great. So my name is Michelle. I'm also a SIG Storage member, and I'm currently leading the CSI Kubernetes integration project. So I'm just going to give an update on where we are with that. So we've made a lot of improvements since 1.0 and 1.13 to help storage vendors write and develop CSI drivers. We completely revamped our documentation page, so hopefully it's a lot easier to navigate now and figure out all the pieces that you need to write a driver. And we've also improved our sample driver, which is the host path 1, so you can potentially use that as a starting point to write your own CSI drivers. Some other great things have been done around CSI driver testing. So for you vendors out there, we have two main tools to help test your CSI driver. First is CSI Sanity Test Suite. And this is actually, this is testing the conformance to the CSI spec, and it doesn't involve Kubernetes at all. So it basically just runs and makes RPC calls against your CSI driver, and with various different good, positive, and negative use cases, and it makes sure that your CSI driver is returning proper error codes and information for each of those. So that's a great place to get started testing. And then, like Saad mentioned, we spent a lot of time working on a pluggable end-to-end test suite in Kubernetes, and this is finally available. And what this lets you do is you can take this end-to-end test binary and run it against any cluster, any Kubernetes cluster, and any CSI driver. And it's pretty easy to use. You just have to download the binary, define a config file for your driver, and the config file just has some information like the name of the driver, a storage class for that driver, and then the features that that driver supports. And then that tells our test framework which test we should try to run against the driver. So it's really simple to use. You can find the documentation on how to do that on the link here. And then for future work, we plan to eventually turn this test suite into a conformance or validation test suite too. That way, we can make sure that all CSI drivers will meet some minimum, quality and stability bar, and users can expect, portable functionality across the various CSI drivers. So now I'm gonna go into talking about what features that we're working on in CSI and Kubernetes. I basically split this up into two main sections. First is achieving feature parity with the in-tree core Kubernetes features. And this is basically about making sure that functionality, all the features that you can do with in-tree volumes today, you can also do with CSI drivers. So I think Saad mentioned a few of these, but I can go down the list again. First, we have volume attach limits. So this is about limiting how many, certain storage drivers have maximum limits on how many volumes can be attached to a single node. And so this is about surfacing that information in CSI and making that available, known to Kubernetes too. Next is making sure that all the capacity usage metrics and also the volume operation metrics that we have in tree also work for CSI. Then we have raw block, which is giving containers the ability to access the raw block device instead of going through a file system. Volume resizing, which gives the ability to expand the size of your PVCs. And then topology, which is making the Kubernetes scheduler aware of volume constraints for specific volume types. So those are all the feature parity features that we're working on. I think most of these are in beta right now, so except for resizing, which is alpha. But we plan to make steady progress on these, so hopefully by end of the year or early next year, most of these features should be GA. Then we are also starting a lot of development on new use cases. So these are things that are not really supported by in-tree drivers today, and these are things we are looking to add and only add for CSI volumes. So I think Saad talked about ephemeral volumes. So this is basically the equivalent of things like empty dir volumes or secret volumes in the in-tree, but now we're making it available to CSI. This is really exciting because it opens up a whole lot of use cases of potential ways to use some specialized volumes. Next, we're also looking into Windows support. So currently CSI only works on Linux systems because it depends on a lot of Linux-specific features. So part of this effort will be figuring out if there's a Windows equivalent, and if not, what can we do? But I think there's some good promise here in the initial investigations, so we should be able to have alpha support for Windows also within the next few releases as well. Then we have volume cloning. This is the ability to make a copy of a PVC. And then also Saad mentioned we are making a lot of effort around extending the snapshot use cases. So we have group snapshots, which is a way to atomically take snapshots across multiple volumes. And then we are working with SIG apps very closely to develop application snapshot and backup functionality. So this is basically the ability at the application layer to take a snapshot of an application, which might consist of more than just the data volumes. It could also consist of configuration and other information. So we're working very closely with them on this effort. So I think that's all I have on the CSI update. So hand it off to David to talk about migration.
All right, hi. I'm going to talk to you a little bit about our current project, which is alpha in 1.14 and alpha in 1.15 that I'm super excited about. It's called CSI Migration. For those of you that don't know, basically what this is, or to kind of set the stage, the way we've interacted with storage plugins and volumes in Kubernetes thus far has all been through the entry plugin API. So this is if you're using any of the cloud drivers, NFS, or like any driver in Kubernetes. You can see I've added a storage class here where you have the provisioner kubernetes.io/something, right? In this case, GCPD. That's how you interact with it. Those are all entry storage plugins, right? So these are all actually code that is built into the Kubernetes binary. They're all in the open source Kubernetes/Kubernetes repository, right? And this is all like what we're using right now. So we also know that CSI is this thing that we've been working on, right? This is an actual extension mechanism. So these are called plugins. These old ones are called plugins, but really they're all built in. We have CSI, which is now the actual extensions mechanism. So vendors can write drivers that are external to Kubernetes that we can then kind of really plug in and install and uninstall into Kubernetes dynamically. So we have these two pieces, and these are actually separate pieces right now, right? We're maintaining, as a driver vendor, you would be maintaining both the entry and your CSI driver. So CSI migration is basically an effort to consolidate that by shimming the entry plugin implementation. So any plugin that exists entry right now, we want to shim the implementation to the respective CSI driver, right? And the reason why we're shimming it and not just getting rid of it entirely is because the entry plugin API is actually a part of the core Kubernetes API, and we can't break backwards compatibility with that. Not until Kubernetes v2, which is not really on the plate right now. So basically, we're trying to continue to support this API, but pull out the implementation from the entry part and replace it with the CSI backend. So with this project, basically the main goal is that nothing changes from the end user perspective. As someone using an entry plugin in the past, I can continue using my entry plugins in the future, right? This is mainly to support upgrades. If you're upgrading a cluster, you don't want all of your volumes to just stop working all of a sudden. So the main goals are that the end user doesn't see anything and that no real end user action is required. So as someone that is using volumes, you don't have to change anything. Okay? And when you look at your API objects, they shouldn't change at least too much. Okay. So why are we doing this? I guess I kind of alluded to this a little bit, but basically some of the main reasons are here. We want to reduce the maintenance burden. So if you're maintaining two separate drivers, right, that's two separate code bases you have to work on, one of them inside Kubernetes, which is not ideal. We want to decrease the security risk of Kubernetes in general. So that's when we remove specifically all of the cloud provider entry drivers from Kubernetes, we're able to actually pull out all of the cloud provider dependencies. So this is actually code that's been built into the Kubernetes binary. We can pull that all out. And everyone knows that. You might have seen the, I think, OpenSSL or something hack where someone injected some malicious code inside a dependency to the project. So the less dependencies, the better. We're going to fix that up for storage. We also want to improve bug fix agility. So that's basically letting, like CSI drivers in general, one of the main value propositions of CSI is that you have increased agility in patching your drivers. You don't have to go through this whole Kubernetes process, like release process. You don't have to conform with the minor release versions or any of that. You can release your CSI driver at your own rate. And if your customers need that update very quickly, you can just kind of push that update to them, and they can grab that new driver and install it onto their cluster if they so wish. But also this CSI driver, when we migrate and move the backend implementation to it, you can patch that as well, right? And the fourth point is to improve the stability of core Kubernetes. So we want to basically remove all of the proprietary code from the entry from built-in to Kubernetes to out of tree now. So when you have a CSI driver that's serving the backend for all of your volumes, if that crashes, that doesn't bring down your kubelet or your kube controller manager or any of your main Kubernetes binaries, right? So just the driver goes down, and since it's in a pod, maybe it can come back up and recover. But you don't bring down Kubernetes with it. So those are some pretty big benefits. You might be wondering when this is going to happen. So we went alpha in Kubernetes 1.14. So actually you can try it out as early as 1.14, but only for provision, attach, mount, and the undoing steps of those. So delete, unattach, or detach, and unmount. So basically like the core, getting a volume and using it, that's migrated. So what you would need to do is just turn on the feature flags. And this is, by the way, only for GCE and AWS right now. The other volumes will come in waves. So yeah, to add to this, I didn't actually add this to the slide. We're planning to do cloud providers first because a lot of these benefits are cloud provider specific, but we do plan on having the rest of the entry plugins come out maybe a quarter or two afterwards. So it's going to happen, but we're pushing the schedule. We're doing them in waves. So in Kubernetes 1.15, like Saad mentioned earlier, we are alpha again, mainly because of a dependency on some alpha API fields. But we're still adding all of the functionality to complete the feature that we were going to do for beta. So that includes functionality for inline volumes, resize, raw block, and attach limits. So these are all, as Michelle also said, the feature parity features for CSI. And in order to migrate all of the functionality of an entry plugin seamlessly to CSI, we need to have the feature parity, right? And so we're able to shim all of those operations from entry to CSI as well when we have CSI feature parity. So we're working on the migration bit for that as well in 1.15. And so after that, this is all speculation, but you know, these are our goals. In 1.16, we plan to go beta. Basically, we're adding functionality for some kind of edge cases as well as metrics. And we're adding more testing. So even for Alpha 2, we already have some pretty good testing. Basically, we're running all of the current entry E2E tests for Kubernetes. So the amount of testing confidence that we get for entry plugins, we'll also have for migration. We have that right now. All the tests aren't green yet. We're working on that, but those tests exist. And in the future, so as I said, we're going in waves. The timeline has not crystallized fully, mainly because migration has a dependency on driver installation. So in order to migrate your entry plugin to a CSI driver seamlessly without any users noticing, your CSI driver actually has to be on the cluster, right, for this backend shim to work. So this is still sort of an open question. There are efforts for specific CSI drivers to get those installed, but we don't really have a good open source solution yet. We're starting to work on that now. But GA of migration depends on that, right? We're not going to just turn it on and not have an answer for how is your CSI driver getting onto the cluster. So if you're interested in working on that or helping with that, you can contact me as well. I'll put my contact information there. So also in the future, we're going to, in order for cloud, okay. Sorry, I forgot what I wrote on my slides here. Basically, for a driver to go GA with migration, they have to support it. Then they will have to qualify. This is based on testing and having some sort of testing infrastructure in place that we can see and monitor and make sure in Kubernetes, like that the Kubernetes SIG storage is confident that this migration will succeed. Then we can go GA for each driver on its own timeline. Okay, and then cloud drivers is kind of the next wave. All right, if you're working on a CSI driver that directly replaces an entry plugin and I haven't reached out to you yet, please contact me at dyzz@google.com. I know for a fact that I've contacted all of the cloud driver people, but if you're working on one of the other entry plugins replacements, I may not have contacted you yet. So please reach out and we'll chat. If you are working or interested in working on CSI migration or the open source CSI driver installation effort, you can join the working group on the Slack. So that's kubernetes.slack.com. We have a channel there. It's working group-CSI-migration. And we have weekly meetings for the migration shim. So this is the actual shim piece that is common among all the drivers. So we're still working on that, and we have weekly meetings for that you can join if you're interested in working on that as well. And if you're an end user of volumes, basically not a CSI driver implementer or working on the shim, you can just kind of wait. And eventually we'll have this working, and you won't notice anything, but you'll be using a CSI driver in the back end. I think that's all. And again, there's my contact information if you need to contact me for anything. All right, now we're opening the floor for Q&A. Thank you.
All right, let's see if this mic works. Testing, testing. Okay, cool. So I'm going to pull up a few folks who've been involved with SIG storage for a while. First up, we have my co-chair, Brad Childs. Brad, come on up. Hello. Then we have Jan Shefranek. Jan is one of the tech leads of SIG storage. He's written a lot of the persistent volume controller. If you've ever seen the Hacker News article about keep the space shuttle running, he's responsible for that code. Then we have our other tech lead, Michelle Wu. She is responsible for the entire CSI stack and has been doing a lot of work pretty much across every feature in the volume subsystem. And then we have David Zhu, who is responsible for the CSI migration effort. And there are a lot of others, including Aaron Boyd, who are here but need to run, and Patrick Oley. We'll probably defer questions to them as well. So let's get started. Who has the first question?
Thank you. What I was not finding in the presentation is security. Are there any plans to work and tackle file system access control security in the sense that you have an acting user and groups that are associated with a pod, and then file system access control like Unix permissions and ACLs can be applied?
Yeah, that's a great question. Who wants to take that one? Michelle, Jan? File system access? Working on security?
Oh. From the security point of view, we have just two very simple features, which is FS group and supplementary group. So far, they were kind of useful, but still kind of clunky to use. So if you have a better idea how to secure the data on a file system, come to us, come to SIG. Do we have SIG security? We don't. SIG off. There is SIG off. Come to us. Uh, we know it may not be sufficient for everyone, but that's the all we have.
So we're actually actively working on rewriting some of the UID, GID handling, because there's issues with brownfield data and having, the time it takes for recursive permission changes. So we know that this is an area that needs some work, and it's a thing, we didn't really list it on our next milestone deliverables, but it's in design discussions right now, and so if there's people that have opinions on it or ideas of ways that we could do it better, we're open. This is something that we're actively talking about.
All right, next question. Let's take you, and then we'll go there. No problem.
Thanks. So the local PVs, they are cool. One problem with them is that obviously because they are kind of tied to that node, all nodes have some form of or some life cycle. So eventually the node will be killed, and you have the need to migrate that local PV on another node in the system. Is there anything planned with the cloning features or similar to make it easier to automate that flow at scale?
Michelle, you want to take this one?
Yeah, so this is a really tricky problem because it really depends on the application layer and how they manage their data. The original thought of local PV is to serve as sort of the lowest, simplest layer for other storage providers to build on top of. So the idea is that other storage systems can be developed that have more intelligent logic to do migration of data and to provide a more consistent file system layer. And I think this is something that maybe OpenEBS might be doing. Are there any OpenEBS people here? No? But I think they've been looking at building sort of a unified data management layer on top of local PVs. But
storage products do support this, right? Like that's part of their platform.
Mm-hmm.
Is
Yeah.
to allow shoot a node, move the data someplace else.
yeah, so in terms of the feature from the SIG storage perspective, we do not have plans to add more advanced functionality to local PVs. The idea is that other vendors can build on top of it and offer that advanced functionality.
Okay, we'll go to over there, and then we'll.
Hey, it's sort of related with a previous question. Some people are fortunate to work on the cloud, it's really nice, but some others have to work on bare metal or on premises. So local storage is something that you want to leverage. It's super fast, and I don't see anything in the plans for local storage. Moreover, how do you enforce limits there? For example, you use some ephemeral storage, and some applications could use some ephemeral storage, which is local. Can you limit it? Because some bad citizen can take up all your root drive and kill your node, right? Are there any plans on local storage?
So to clarify, you're asking about controlling usage of ephemeral local storage?
Local storage in general. Ephemeral I mean part of it, because maybe it's something that it's less easy to ignore as a functionality.
Okay. So from the persistent local storage standpoint, what we currently recommend as the model is to represent every individual disk as a PV. That way, your capacity and IOPS are not shared across multiple users. For the ephemeral local volume or local storage case, where basically all pods are sharing the same local file system. We currently have the capability to do capacity isolation. So you can request limits, and you can request a limit on your empty dir volume. And we will schedule pods only if there's enough local space left. And we also do periodic monitoring of the ephemeral local space and evict pods that have exceeded their limits. So for that, we do have capacity isolation available, and there are talks in the work to potentially add IOPS controls using like the C group IO scheduler.
And to add to the first question that was asked, which was, what is the roadmap for local storage? I want to reiterate something Michelle said, which is local storage local PVs are intended to be a primitive that you use to build higher level storage systems on top of. So you're not going to see things like us handling replication or moving data around. The idea is that Kubernetes provides you that abstraction layer that you can build on top of. So you can take that primitive and deploy a software-defined storage system on top of it. Could be open source, could be proprietary, and that software-defined storage system then itself exposes a blocker file, and then you can consume that. So if you have additional requirements on top of what the base disk provides, then take a look at these other options.
And keep in mind, like, this is like a recent feature. Like, this is the end of the feature path, right? Like, we are still accepting requirements and still working on it. So I think some of these things, we may add in the next couple of releases if people are interested in something.
Okay, I think there was a question here, and then we'll go over there. Okay.
It's not really a question, rather a follow-up on everything related to local. What was mentioned before, the provisioning of disks to PVs or directories on the host. It's something we've been looking into recently as well. I was wondering, how can we work with the community, you guys, in designing a solution for this, ideally reusable by other platforms as well. So how do we collaborate on this rather than we can build a CRD, we can build an operator, we can get everything to work, but then no one else gets any benefit out of it?
So I can just yell, let's do it. We had weekly design calls for this. We kind of tapered it off as the solution got, solidified. We can start up, maybe weekly or bi-weekly design calls and just, do participation there. Typically, we start with a storage SIG, the bi-weekly calls for the general SIG, and put it on an agenda item if you have something specific you want to talk about. And then we can break it off into like a separate call, where it's a deeper design discussion.
Yeah, and to add to that, there's definitely been a lot of requests to support dynamic provisioning of local volumes. So if you're interested in pushing along the design and helping with that, I think join the SIG Storage mailing list if you haven't already. I will try to send out an email and organize some new regular meetings with this, because I think there's a good amount of people that are interested and willing to help discuss.
So we should have had a SIG storage section to this, or the local storage section to SIG storage.
Next question, I think, was somewhere over here. Sure.
Hi. I want to ask about CSI. When you designed it or thought about it, when the use case is for a storage vendor to supply multiple boxes of, let's say, the same type for a certain client which implements Kubernetes Cloud, how do you perceive, for example, how many does the user will need to create a separate storage class for each box, or do you think that a single storage class for all the boxes, or there should be a certain entity that look over all the boxes and allocates the storage.
What do you mean by boxes? Like storage systems?
Yes. Storage systems.
I think I can take that. So if I understand your question correctly, it's you have multiple storage systems available to your cluster, and how do you foresee, should it have multiple storage classes on your cluster or a single to handle all of those storage systems? So the pattern that I've seen most often is separate storage classes for each storage system that you have available, as well as even within a single storage system having multiple storage classes for the different grades of storage that you want to expose from that storage system.
That will be a little bit difficult for the customer to go and write all these storage classes.
Yeah, that's a good point. And generally, what we recommend is storage vendors provide the storage classes to the customers. And so, as part of the CSI driver installation process, it just installs the storage classes as well.
Yeah, I had a question. I saw on the slide that snapshotting, being able to quest and then resume. I'm just wondering how that actually works, and is it a per application, or how do you hook it into the application to do that?
So that's a good question. So the question was about QS and un-QS and how you're going to hook that up. So the conversations initially started off at the volume layer. This is what we're responsible for SIG storage. But what we quickly realized was that, at least for QS un-QS, that's the wrong layer to introduce it at. So we're working with our partners in SIG apps to introduce a higher level functionality for managing stateful applications. And I believe, I'm not sure if the KEP is out or it's going to be out soon, but there's a KEP that's going to be introduced to say, here's how you define what a stateful application looks like, and here's how you take a snapshot of a stateful application, and then the QS and un-QS hook would happen at that application level to give you application level consistency.
So regarding the CSI plugin upgrade process, is there any recommendation to avoid having downtime on the plugins? Because as I see the CSI spec, for example, it specifies that all the plugins deployed should be returning the same value, for example, in the plugin capability reporting. So if you have a CSI version that doesn't support topology, and now you're rolling out a new version that supports topology, you cannot have just do a roll upgrade and have some plugins reporting that they support topology while others don't, at least according to the spec. So is there any recommendation to do an upgrade?
Anybody want to handle CSI upgrades?
It seems like you guys came up with like all of our sticky points that we've been having troubles with. This is definitely one of them. It depends a lot on the storage, the actual storage vendor and how their drivers work. We have issues potentially with daemons running in containers and having to restart containers as if you deploy a new driver and your old driver had a daemon in it, like the stop and the restart is going to do something, it's going to cause some downtime. Similarly, if your new CSI driver has different properties or parameters, you're going to have potentially an operator or something do manage or help you manage the upgrade with it, right? And so I think that's probably the ideal path is to write an operator that helps you do the upgrade from one CSI driver to the next. You should know it as a storage vendor. If you're going from version 1.13 of your CSI driver to 1.14, you would know the property differences between the two, right? Or like whatever features weren't in the old one but are in the new one, you should be able as a storage vendor to handle that upgrade. We can't really do that, at the framework level. It really needs to be something the storage vendor handles, and that's usually done in an operator.
I guess you were asking about topology as a specific example?
Yeah, because it's one of the features that are reported as a plugin topology, right? It is one that is reported at that level.
So you're saying that if the validate volume capabilities gets called, then that's going to fail if the driver's not fully upgraded? Is that what you're concerned about?
The thing is that from the CSI perspective, ignoring if it's Kubernetes or somewhere else, all your CSI plugins are supposed to be reporting the same values at a given time. The spec says all your plugins, node and controller should be reporting the same values in that call.
The concern about mixed version plugins?
Right. Just to rephrase, I think if you have like a plugin that's halfway upgraded, then half of them are responding with one like capability set, and then the other half are responding with another capability set. And I think your concern is that this is not CSI spec compliant.
Yeah, so I think the volume capabilities are reported at the controller level. Is that right? Okay, so at least for the controller level capabilities, like topology, you'll only have one active controller running at a time. So when if you're using multiple controller ones for like HA, but you'll have leader election there, so you only have one active. So in that case, when your driver's reporting something, it should only one driver instance will be reporting its capabilities. I think from the node side, the way that we have to handle that in Kubernetes is to have Kubernetes able to handle version skew between nodes and drivers. And for the most part, like any new feature that you enable, like it will not fully function until the whole Kubernetes part has been upgraded to support it, if that feature requires both master and node components.
So the idea is for Kubernetes to see that there is a discrepancy and not use the feature?
Yeah, so at least the way that topology is implemented, because topology depends on both the API server and the kubelet versions, the Kubernetes sidecars that handle topology will check the version on the kubelet, and if the version on the kubelet is too low, then we ignore topology. So basically, topology is not going to work until your nodes have been upgraded to the minimum version that supports it.
Yeah, I was more worried on the other way around, that the Kubernetes supports it, but the CSI plugin doesn't get it, and suddenly you add the feature.
Right. Would you have to do the same thing for the driver?
Mm-hmm. Yeah, I need to think through that exact thing. I don't know if do you remember how we did it in the PD driver? Did we have?
Yeah, we'll take this offline.
Version skew is a very complicated problem, and there are things that we try to do on the Kubernetes side to try to simplify it, but it's going to be something that the vendor also has to look at, and we have to look at it on a feature-by-feature basis. But we're happy to work with you on any specific feature that you're concerned about. Any other questions? Okay, let's go back there and then here.
Thanks. This is more a question of bureaucracy, really. I was at the intro and deep dive of CNCF's working group, which is turning into a SIG. I think it was Alex Chirkop. So I'm slightly confused as to what the intersection and differentiation is between the two SIGs here.
Sure. I can take that. So the question is, what is the difference between the CNCF storage work group, which is now being turned into the CNCF storage SIG, and this Kubernetes storage SIG? The purpose of this Kubernetes storage SIG is very clear. We are responsible for the Kubernetes storage API as well as CSI, and figuring out how Kubernetes integrates with storage. The purpose of the CNCF storage work group is to act as a educational entity for the CNCF steering committee as well as CNCF users. So the kinds of things that you're going to see out of that group are they put together white papers and they kind of funnel information into the TOC in terms of storage. They do the research and they pass that along, and then they publish out information as well to CNCF users to kind of clarify the landscape and that kind of thing. The charter may evolve over time, but that's the core of what they are responsible for today.
It's also new, just to add, that's just recently been formed. And the idea was the TOC hasn't scaled to the point that they're getting projects. I mean, if you've seen the evolution of the CNCF, they just can't keep up. So they're looking to the storage community to help vet new projects and understand it beyond Kubernetes. What are other cloud-native storage systems, and what does that look like, and what kind of standards, I hate to use that word, no one likes that word, but it's true, should we be complying to make sure it's, cloud-native, things like security, with the broader ecosystem. So that's the point of that. But, I mean, everyone should try to get involved in both. We shouldn't operate outside a vacuum. And so I encourage people to also start attending those meetings, because it just got approved yesterday. So, okay.
And then over here.
Is there any plans to have some kind of scheduling for selecting the storage classes? Because basically, many users just, I want storage that have these features. And then, currently is that, you need to see what your cluster has and select the one that fits. But is there plans to make it more automated, that you could say, I want these and what cluster might have, then somebody would select, this suits best for you?
No. So the idea with the storage class is it's the responsibility of the storage admin to communicate what storage classes a user should use and when. It's not something that we wanted to display or try to catalog at the framework level. It was kind of something that we left for storage admins to determine how they're going to communicate that to users effectively.
If you are looking for different default storage classes for different users, then the default storage class we have right now is just admission plugin. You can disable it and write your own and use whatever criteria you want for your PVCs. So that's the easiest way.
And one more thing I'd add to that is one of the cornerstones of this SIG and the APIs that we put out is portability. So when we look at modifying anything in storage class or PVCs, we're very careful about making sure that we don't do anything that compromises that. So as far as we're concerned, storage class is an abstraction. We don't really try to select what's under the layer at our Kubernetes layer. So we try to avoid that as much as possible. Next question. Sure.
I have already asked something similar at the storage day, but so there is this migration effort. Is there any plan to change the way how the CSI drivers are registered nowadays? So currently I should use the sidecars. So it's almost like no support on the Kubernetes side because it's supported by the sidecar. So any plan to do some webhook to inject the sidecar part, or a tool which can generate the sidecar to an existing YAML file, or I don't know, any other plan to improve that part to make it easier to start the CSI driver itself.
What is your concern with the sidecar?
So I have a CSI driver, and I have a few other developers, and I tried to explain why do I need so many details in the required Kubernetes. And they said, oh, the Kubernetes supports CSI. Why should we need all of these details and all of the things? So I would like to make it easier to the other operators to start my drivers and to understand what's going on and how can it be started.
So CSI drivers are broken into, or they have two pieces of registration. One is registering with the node. So anytime you deploy, there's something that goes on the node and it registers with the node. And a second part that registers with the controller, the cluster-wide, to say I am a CSI driver that is available on this cluster. That second part is optional. If you don't do that, Kubernetes just defaults to a default set of behaviors for that driver. The reason you would want to do that is visibility to the user, and second is customizing how Kubernetes interacts with your driver, like skipping attach.
I think I used the wrong word. So it's not about the registration,
Uh-huh.
but the translation of the persistent volume claim object events and the CSI calls. So this is what the sidecar can do.
Yes.
And this is not part of the Kubernetes, but it's in a very visible point.
Right.
It should be added by me
Yep.
to my CSI driver.
Yep.
And it would be better if it can be added by a webhook or by a tool.
Right.
That's what I'm thinking of.
So let me see if I can restate your question. It's currently CSI requires sidecars to call out to Kubernetes, monitor the API, and then call out to the CSI driver. You're asking, eliminate that sidecar, have Kubernetes call out to the CSI driver directly?
It's one way to eliminate the sidecar. The other one is just provide tool to add the sidecars.
Yeah.
Right?
So that's a...
I'm just wondering because for the migration project,
Yeah.
it could be the same problem, right?
Yeah.
There should be another way to migrate the internal CSI drivers.
Sure. So let's take that as two pieces. One is for the node. So on the node, this is exactly how the kubelet operates. The kubelet, once a CSI driver is registered, the kubelet calls out directly to the driver and interacts directly with it. The only part that you need the CSI driver for on the node is registration. So you could eliminate the sidecar there and just somehow do your registration manually. Really, all you need to do is drop a Unix domain socket in the right place. So you could eliminate the sidecar there. For the controller part, it's much more difficult to eliminate the sidecar. The initial design of CSI, we were thinking about having Kubernetes call out to the CSI driver everywhere, but what we quickly realized is outside of the node, it becomes very challenging. How do you do service discovery? How do you do authentication and authorization to ensure that nobody else has access to this endpoint that you're going to expose? And so instead of trying to address all of those problems, what we decided to do was go with the native Kubernetes model, which is every component is responsible for its own logic. And so we, instead of putting all of that logic inside of the master and having it push out and make the master very complicated, we did what every other component in Kubernetes does, which is have the component itself reach out to the master, figure out what it's supposed to do, and then do it. And so that's why you have these sidecar containers. But again, none of this is required, so if it doesn't work for you, the minimal requirements are that you have something that can read the Kubernetes API and call out, so you could like build that into your driver if you want and eliminate the CSI driver car.
That's not CSI anymore, right? That's the old way to check the...
No, I mean, it's still CSI. You would write a CSI compatible driver. You would just merge the sidecar container into your driver. But good question.
I'm interested about just some kind of improvements to make it easier to inject or...
To do the migration, yeah.
Because now it's visible, the internal, so I totally thank you and I can understand the reason.
Sure.
I'm just interested if these internals can be more hidden.
Yeah, David.
Admission webhook or I don't know.
Yeah.
Yeah, yeah. So I think what you were asking is like, okay, we need the sidecars, but is there a better way that vendors can develop and deploy their drivers without having to actually like manage the sidecars in the spec? Yeah, because like if you look at other projects like Istio, they have an admission controller that just automatically injects sidecars into pods. Right, so you're asking if we can do something similar for CSI drivers. So I think it's an interesting idea. We haven't really thought through about it. There might be, I think, we can start the discussion on that, but I think there will be a lot of interesting things to consider, like if what happens if a driver needs special parameters customized in the sidecar and tunables and stuff like that? How would you sort of expose that, you know, to have us inject the correct sidecar with the correct arguments and the correct versions? So there's a lot of things to think about if we wanted to go towards that model.
I was having that exact discussion with somebody, I think yesterday, who was asking about the feasibility of moving the logic of the external attacher and the provisioner back into the kubelet code. Could that be something we'd look into? At least those two sidecar possibly could go away. So if it's something that we're thinking about, maybe we should start a discussion and see how it goes.
Cool, yeah, we can follow up about that. Any other questions? All right, then we'll wrap it up. Thank you very much for your time, and I'll put up the information about the SIG. If you're interested, please reach out and get involved. We're always looking for new contributors. Thank you very much.